So we'll be using some Neocube balls to illustrate some concept of the magnetosphere. If you have a closed loop, you can see that the magnetic field is within the loop, and then playing with the loop, you play with the magnetic field. So a chain like that can be connected to a sphere magnet here. So we got a magnetic sphere in the center that looks like the Earth, and you see on both sides a magnetic field a bit like the magnetosphere. So I won't go into the details of all the axes shifting causing the seasons and stuff, but just to show that a particle would be stopped by the dayside magnetosphere protecting the Earth. But a particle coming from the Sun could also enter directly on the Earth through the polar cusps. And we'll see right there that it can reach the Earth directly. So again, if we take the Earth and we look at the polarity of these loops, we can have a loop coming from the Sun. Let's just pretend that the Sun is sending us magnetized plasma bubble. Depending on the polarity of that bubble, you can have an interaction. In this case, both fields are opposite and they will cancel at the connecting point, so the bubbles can reconnect, the fields can reconnect. If we have an inverted polarity, I'll just flip around like that and change the arrow. Let's show the field here. We'll see that both fields add up at the junction. So we've got a non-zero field at the connecting point. So the loops won't want to merge. And in this case, the dayside magnetosphere would shield the Earth from the particles from the Sun. See, it doesn't want to connect. So the plasma bubble could be transported to the night side by the solar wind, and when it reaches the night side, its polarity would be such that the merger could take place at this point. So these particles from the Sun could reconnect to the night side magnetosphere and charge up the magnetosphere for maybe triggering substorms in the long run. So again, you can have different configurations depending on the solar wind seasons. Here we'll see if the magnetotail is long enough and there's enough outwards pressure, you can have reconnection in the tail, and that's going to leave us with, instead of having one big loop, having two big loops that can be separated. So there's going to be plasma released in the tail, and the field lines will reconnect and inject energy, so that would enhance the auroras. That would be some kind of substorm created there. This is tricky to do because the field lines will want to interfere, but this is just to show that the further the line goes, the higher towards the north it reconnects. So you can map on the surface of the Earth different places according to their distance. And when the solar wind blows on the night side, the field line will be stretched, bringing those connections southwards. That would be why you can see auroras closer to the equator when there's very active conditions,